Hi everyone, so this is my presentation for the discussion to motion of particle along a straight line question. So this is a position versus time graph. So I look at the slope to determine the particle motion. When the graph rises, the particle moves right. When it falls, it moves left. And when it's flat, the particle just stands still. So basically from like 0 to 1 second, the velocity is positive 2 centimeters per second. From 1 to 2 seconds, the velocity is 0 because it's not moving. So as it goes up, it's positive, and it goes right. As it goes from basically from 2 to 3, it's flat, it stands still. As it goes from 3 to 5, so from here to here, so that becomes negative and it goes left. As it goes from position 3 to 5, because it's flat, it's not moving, it stands still. And from 5 to 6, the velocity is -2 because it's still going down, it's going left. So the speed is the absolute value of velocity. So the speed are like 2, 0, 4, 0, 2. So as you can see here, here for the speed. And because speed is always constant, it's always positive. Velocity is something different. So as you can see here, to find the velocity is change in position over change in time. So from 0 to 1 second, the position increases by 2 centimeters over 1 second. So the velocity is positive 2 centimeters per second. From T1 to T2, the particle stays at 2 centimeters. And from the 2 seconds, the position does not change, so the velocity is 0. From T2 to T3, the particles move from 2 centimeters to -2 centimeters. You can see right here. Hello. Hi. So, from the 2 to 3 seconds, the position decreases by 4 centimeters in 1 second. So the velocity is negative for 4 centimeters per second. Negative sign means it's moving left. Precious. So from T3 to T5, the particle stays at -2 centimeters. From 3 to 5 seconds, the position stays the same. So the velocity is 0. From T5 to T6, from 5 to 6 seconds, the position decreases by 2 centimeters in 1 second. So the velocity is -2 centimeters per second. So to find the velocity, I calculate the slope of each straight section of the position graph. I use the position and divide it by change in time. So from 0 to 1 second, the velocity is positive 2 centimeters. From 1 to 2 seconds, it's 0 because the particles is straight still. From 2 to 3 seconds, the velocity is negative for 4 centimeters per second. So from 3 to 5 seconds, it is 0 again because it's not moving. And from 5 to 6 seconds, the velocity is negative, so 2 centimeters per second. So positive velocity means movement, so to the right. Negative velocity means moving to the left, and 0 means particle is standing still. So because the particle is never speeding up because the velocity stays constant on each interval. The only time the velocity changes are at the corner of the graph where the velocity is not defined. Since the graph is straight line segment, the velocity is constant on each interval. Constant velocity means acceleration is 0, so the particle is not speeding up at any interval. And in the corners, like 1, 2, 3, 5 seconds, the velocity changes, so it's not defined. So how about that? Have my notes. Make sure. And that is my presentation. Goodbye. Thanks, guys.